Hello gentlemen, welcome to section 2.5 on the periodic table. Now the periodic table was developed by a guy named Dmitry Mendeleev. And the periodic table is the most significant tool, the most useful tool that chemists use for organization and remembering chemical facts. And it will be the most useful tool for you throughout this class from now on. The elements on the periodic table are arranged in order of increasing atomic number. So if you look carefully, everything increases from 1 till, on our periodic table, 113 to around 118 for other periodic tables. In this order, the elements show a repeating or periodic, hence the name, pattern in their chemical and physical properties. Again, in increasing atomic order, elements show repeating properties of chemical, repeating chemical and physical properties. We'll talk more about that tomorrow in class. Now, the arrangement of elements in order of increasing atomic number, with elements having similar properties placed in vertical columns, is known as the periodic table. So let's talk about the actual organization of the periodic table a little bit. So the periodic table, first and foremost, is organized into horizontal rows and vertical columns. The horizontal rows are called periods. We have 7 different periods. So my sample periodic table here, 1, 2, 3, 4, 5, 6, 7. These are my rows going across. My vertical columns are called groups, or sometimes referred to as families. I have 18 of them. So 18 columns across the periodic table. Now, there are different methods of labeling the groups. We're going to use the traditional North American method, which uses Arabic numerals and letters A and B. Elements, again, in the same group, often exhibit similar properties or similarities in their chemical and physical properties. For example, coinage metals like silver and copper are in group 1B. Group 1B would be here. Silver and copper are both there. They both have properties that made them useful for coinage for, many generations, centuries. And group 1A holds elements that are all explosive in water, excluding hydrogen, of course, which is up here, which is not a metal. Now let's talk about this organization of the periodic table here. My groups, I have Group A elements and Group B elements. Let's split it up that way. Group A are the elements in the towers. Think of the periodic table as kind of like a castle. I have a tower here and a tower here. In the middle, you have the base of the castle and the moat outside, or whatever you want to imagine after that. But your 2 tall towers are Group A elements. You notice there's an A beside all the numbers here. So I have my Arabic numerals, 1, 2, 3, 4, 5, etc. And I have A's and B's next to them. Group A elements are in the towers. I have 1A, 2A, go to the other tower, 3A, 4A, 5A, 6A, 7A, 8A. My group B elements are here in the base, and these elements down here are also group B elements. Now, I go from 3B, 4B, 5B, 6B, 7B, 8B consists of a couple different groups here, different columns, and 1B and then 2B. Now the periodic table is split up generally into 3 major categories: metals, nonmetals, and semi-metals or metalloids. Now the majority of the periodic table consists of metals. There's like an imaginary staircase here. We'll talk about this staircase, and you'll see it on the periodic table in class, but there's a staircase here. To the bottom, under the staircase, and to the left of the staircase, we have all metals. The majority of the periodic table is made of metals. This one up here, however, is hydrogen, not a metal. Above the staircase, we have nonmetals. Elements that are touching the staircase, we call those metalloids or semi-metals, and they're on the staircase. They have properties of both metals and non-metals. Now if we do a little recap here, here's our periodic table. We have 7 periods, 18 groups are going across. Now, we have metals, nonmetals, and metalloids, but we can become even more specific than that. There are different types of metals, different types of nonmetals, and we classify them in different ways. So in group 1A, we call these alkali metals. Alkali, alkali metals. In group 2A, we have alkaline earth metals, like alkaline batteries, those type of things. In the middle part here, this group B, we have transition metals. Under this, we have a group called inner transition metals, or sometimes they're called rare earth metals. Come here to my staircase. Under my staircase, these are oftentimes referred to as just other metals. Above the staircase, these are some generally referred to as nonmetals, but some nonmetals get specific names. For example, elements in group 7A, they're called halogens. Elements in group 8A, they're called noble gases. Next class, we'll talk about these categories and why they're so specific, what makes them special, and something that all the elements have in common in each group, why they have similar chemical properties and physical properties. So I'm going to take notes on this. See you in class.